I want to talk about this structure that I made. It's quite interesting. The structure itself is very simple, but the mechanics of how it works is quite interesting. I'm using the Muay Thai Baiju brand to do this. That's this bottle that is illustrated in here. This was actually motivated by one of my students who was doing some packaging for the brand, a more high-end version that was going to be much more sophisticated and a bit more of a higher price point. A whole new bottle and everything to reinterpret the brand. But I wanted to take some of the feeling of that. What she was using this kind of articulation with the two pieces opened, and it was a really beautiful case-bound package. So I wanted to take the base brand and do something similar structurally, but do it from an economical point of view. So this is going to be a corrugated structure. I'm going to make it out of E-flute. And I just want to show the build sequence on this and how this worked. And I also have another tutorial in Rhino about how I developed the 3D file to get all these parts to work. So let's start with the outer part. So I just directly didn't even create the 3D data first. I went right to a 3D die line, right? Just laid out the part. So it's all about the mathematics. I figured out how much I needed to hold the bottle, and I have a base in here to make this work. So this is basically a double end wall in two halves. So it's all one part, and I just have a hinge in the middle that puts this together. So this is relatively simple, but it makes this whole idea work. The double end wall is this type of idea where we're folding this over and grabbing the tabs. I did not use the slit cuts to create the inside. I'm just bringing the material into the middle. And just by bringing it into the center, it holds itself together. So normally in a double end wall, we have those little cuts here with the tabs that come through, but that was very unsightly because part of my point of view here is I want to use corrugated as a self-shipper, DTC, and keep it as clean and as sophisticated as possible because the brand does have a relatively high price point. So I wanted to do a self-shipper and maintain that aesthetic. So that's the goal. And it was a matter of getting this all to work simply and a little bit more economically. This, for a corrugated box, is relatively expensive, but not nearly as expensive as a case bound or something like that. So actually, both of these work the same way. It's almost like two identical halves, all out of one piece. And that's it. So no glue, just setups. This is made out of E-flute craft. And here it gives us our outer box and how this works. So I've done some pivoting boxes very similar to this, and quite often I rely on more mechanisms where I'll have a molded piece or an assembled piece, and there might even be some screws or pivot points to get things to articulate. But I really wanted to go after this and eliminate all that and make it as simple as possible. So that's why I'm sharing how this works. So this is all one piece, the outside corrugated part. So I developed this tray, which was quite interesting. And I also did that. This just happens to be white, but it's also E-flute corrugated board. And this also assembles with this insert in here. So this is the corrugated part. I think I have a die line here. Again, all one piece, and I'm doing a double end wall type of configuration. It's very similar, but what's key is I have this little V cut in here. So that little detail is going to make this whole thing work. So I'm bringing in this other part here. This I made out of foam core, but what this would be is it would be out of EVA. EVA is a relatively dense, sort of like a foam rubber feeling to it. So it gives a nice soft pad for the bottom of the bottle to sit in case there's any shock. And since it is EVA, it's relatively flexible. So we don't want the bottle to fall through the bottom since I'm suspending it above. So there would be a thin, rigid plate. It might even be a metal plate or aluminum or something rigid that's laminated to the bottom to give us that rigidity, but then maintain that foam type of feeling. Because as you can see, when I put it in here, I am suspending, let me just lock this down. I'm suspending the material inside of this so I can have this little V-cut clear at the bottom, which makes this work. So that snaps in. I have a little support panel here. So with that rigid panel below the EVA, I can get a very strong part because we don't want the bottle to get pushed through here and break into this void because this void will be in the bottom of this box. So that's how this part works. And again, everything can be 100% printed on all these surfaces. So I discovered with this detail, let me go back to my drawing. I made these little, they would be extrusions probably, but I just carved these out of wood so we could see how this was going to work. These pieces sit here on both sides, and what they're doing is they move and they articulate. So our pivot point is here in the center. So as this pivots out, these things change position. So when they're down here, let me get these in the right way. So when they're down here, they are pressing against the tray, so the tray cannot move side to side because I need this little void here, this little space. So when these two angled pieces pivot out into this orientation here, they clamp the bottom of the tray, and that's what keeps it in its open position. So it works quite well, and all I'm using is the configuration of the part. There's no screws and no glue and no other mechanical parts. It's just an assembly, which is quite interesting. So once this part is made, what the fulfillment process would be is you put these little V-cuts down in here. Now here, it actually works without gluing, but I think maybe a little spot adhesive or something like that might get that to work. So this articulation now goes from closed to open with that pivot point. So all that needs to happen is all you have to do is place the tray into position, and it holds. And it comes right up into the bottom of this part here. And then when it closes, it sits right on top. And then the bottle just sits inside. And with the bottle in position, it holds. So now we have all this articulation that's going on. So the one part I do need is how would I close this? And then we're also going to ship it. I want this to be a self-shipper, so I have a lot of space around there. So I developed some other parts that I'm going to put at the top here, also with EVA, and I'm going to put some magnets in them. And they're going to trap the top of the bottle. So I am pushing the whole idea of economics because I am using corrugation. But still, it's corrugation, hand set up, and then inserting these parts to get it to work. So it is expensive for a corrugated box, but not bad considering the price point of this product. So that's how that part works. And I just took that a little bit further and made a nicer version of that so you can see how that looks. So I took some other material. I have white on white E-flute. So this is still corrugated. And I still have my raw edges here, but you don't see the craft board. It's a very clean white on white. I don't have any slit scores for locking together, so that fits together really, really well. But I have some really nice magnets here at the top inside of another EVA block. So this would be an EVA block on both sides, and I would insert magnets inside on both sides. It would be relatively soft. These would be tacked into position, so they're held in. And again, it's the same structure. I just tuned it up a little bit, made it a little bit tighter, so it fits really well. So these other components work in the same way as this, for this part. So by taking these little extrusions and putting them inside, these fit pretty snug. Again, they could be spot glued into position. So by doing that and then just placing this part in here, I get this same kind of articulation going on here. It works. So it's just very nice with the white on white and then putting the bottle in there. Let's just tip this back. Hold on. So we can get this nice kind of closure here. So again, we can have printing on all sides. I just put some red paper on here with a little bit of a diagonal pattern, which ties in with the brand. So that's just for position only, but all the inside surfaces could be printed also. So that's it. When it comes together, it has a nice locking. So actually what happens is not just the magnets, it's the idea that the bottle is sitting into these two notches. It becomes integral with the assembly. It's almost like an interlock. So once this is closed, these can't move because the bottle is trapped in position. So that's ready to go. So I'm not suggesting that we ship that as is. So I'm suggesting maybe an outer sleeve that carries our shipping label. And then that would just fit over the top. And then we could use like a wafer seal or something to keep that into position. And then this would be ready to go. And it would be somewhat protected except for the bottom, maybe the top. So maybe I do use a cover of some kind on there. But I thought that was quite interesting to combine the corrugation with some of these other details on the inside to make this as sophisticated as possible for a folding carton.